All right, let's go ahead and do a problem involving logarithmic differentiation. So the problem or the function that we're given is y is equal to cosecant of negative 7x minus 2 of x, which is a pretty unusual sort of curve, but we are asked to find the derivative. So we've got to find dy dx. And so thinking of, let me go ahead and circle this. Thinking of this as the inside function, actually, before I go that far, I think what I need to do, because this is logarithmic differentiation, let me do that here next to it. I need to take the natural log of both sides. Okay, so it might help if I use brackets here. All right, so taking that natural log of both sides allows me to, first of all, I'm going to copy the left as is, but I can bring the negative 7x minus 2 to the front. And then I've got the natural log of cosecant of x. Okay, so taking kind of a step back, that's not where we're going to work off of, because I need to take the derivative of this and then the derivative of that. Okay, so the derivative of the left is 1 over y dy dx. And then on the right side, we have the product of two functions. So we're going to take the derivative of the first function, which is negative 7x. And then we're going to keep the second function as is, natural log of cosecant of x. And just because of space, I'm going to put the plus sign here because now I'm going to take the derivative of the second piece. But because this is a composed function, or the second piece is a composition of two functions, I need to use a chain rule. Now, the derivative of cosecant, that's why I had that over here, is minus cotangent x cosecant x. So minus cotangent x cosecant x. And to that, we want to multiply the minus 7x minus 2. And so let me just separate these because it might be getting a little confusing where, what's what. Okay, now the only thing left to do is multiply everything by y. So dy dx is equal to minus 7x times the natural log of cosecant of x times y plus, and we'll use a minus sign that's here. So minus cotangent x cosecant x minus 7x minus 2 times y over cosecant of x. And now we try to see if there's any quick simplification. And the only thing I see, maybe move that y to the front, in terms of natural log of cosecant x minus those cosecants cancel, so we're left with cotangent x minus 7x minus 2 times y. And let me just pause to see if that's something the program will accept. So just a sec. Okay, so everything looks fine, except that there's one thing to do, and that is this y here and this y here, we're going to factor it out, or I guess we didn't have to multiply it through. Okay, don't copy that yet, just yet, because I'm going to come back. That's a dy dx. And I'm going to leave this in parentheses. So it's all good. And the reason I left it like this is because what I want to do is remember that this is my y. And so I am going to take my ability to copy this and ultimately to paste it, because I'm going to drop it. It's going to replace the y. And I'm going to just go over it with a pen. So that ends up on the outside. You certainly could leave it where the y was, and the program should accept it. But this is how you do this type of problem.